In this example, we're going to show that matrix algebra does follow the distributive law. We've got matrix A, matrix B, and matrix C, and we're going to show that whether we do this calculation here or this calculation here, we're going to end up with the same answer. So, starting with this calculation here, our starting point will be adding together matrix B and matrix C. So that's what I've written out here. I've got matrix B that I've written out here and matrix C that I've written out here. Now, for us to be able to add two matrices together, we need to make sure, first of all, that they have the same dimensions. In other words, we need to make sure that they have the same number of columns and the same number of rows. And that is the case here. Each of these matrices has got 3 columns, 1, 2, 3, 1, 2, 3, and 3 rows. Okay, so we've established that, so we can add them together. And in order to do that calculation, we need to take, for example, this element, first row, first column in matrix B, and add it to this element in matrix C, first row, first column. 6 plus 3 gives us 9. Here we have the element in the first row in the second column. We add that to the element in the first row, second column from this matrix, in this matrix here. 2 plus 4 gives us 6. And so we continue. 1 plus 1 is 2. 1 plus 1 is 2. 2 plus 2 is 4. 2 plus 1 is 3. 1 plus 5 is 6. 1 plus 1 is 2. 3 plus 2 is 5. Okay, so this here is the answer when we add matrix B to matrix C. So we've done this part of the calculation here, but now we need to multiply this matrix here with matrix A. So if you take matrix A, write it down here, and it clearly is the first matrix that we are writing down. So this is now known, this is our lead matrix in this calculation. B plus C, this matrix here, I've written it out here, and this is now our lag matrix. So before doing the multiplication, we first of all need to check whether these matrices are conformable for multiplication, and for that to be the case, the number of columns in the lead matrix need to equal the number of rows in the lag matrix, and that is the case here. We've got 3 columns and 3 rows, which means that we can go ahead and multiply these two matrices. In terms of what our product matrix will look like, the dimensions of the product matrix, it will have the same number of rows as the lead matrix and the same number of columns as the lag matrix. So if we denote each element of the product matrix with a C, we can write out each element as follows. Okay, we know, because we know the dimensions of our lead and lag matrices, we know what the dimensions of the product matrix will be. 3 rows and 3 columns. Okay, so in terms of finding the values for each of these elements, what we need to do, for example, to get the value for this element here, we need to multiply all the elements in the first row of the lead matrix by all the elements in the first column of the lag matrix. Okay. Similarly, if we pick another element, if we take this here, if we want to know how we're going to calculate this value, we're going to multiply the elements in the third row of the lead matrix by the elements in the second column of the lag matrix. So if we now do that calculation, it can take a fair amount of time if you write it out in full, but I think it's quite helpful, especially now, just to write it out so that we can see how we get each of these values for the elements in the product matrix. So starting with C11, first row, first column. Okay. All of these elements here, 2, 1, 2, we need to multiply by these elements here. Okay, so 2 times 9 plus times 2 plus 2 times 6. Okay. Second row, first column, second row of the lead matrix times the first column of the lag matrix. Second row, first column, 1 times 9 plus 3 times 2 plus 2 times 6. This element here, third row of the lead matrix times first column of the lag matrix. 5 times 9 Okay, so we now continue with our calculations. For this element here, we need to multiply the elements in the first row of the lead matrix by the elements in the second column of the lag matrix. First row, second column. Second row, second column, second row, second column, third row, second column, third row, second column, okay, and we can move on to this final column here now. First row, lead matrix, third column, lag matrix. First row, third column. Second row, third column, second row, third column. Okay. Lastly, third row, third column, third row, third column. Okay, so these are all the calculations written out, and the next step is obviously just to work through these. So if we continue with our calculation, let's just work through all of these, and again I'm just going to write out everything quite clearly before we add everything up. Okay, so taking it quite slowly, but at least then you can see where all the values come from. Okay, so we got 2 times 9, 1 times 2, 2 times 6. Okay, 1 times 9, plus 3 times 2, 6, 2 times 6 is 12, etc. Alright, and if we add all of these up now, we end up with 2, 7, 2, okay, so we're really only halfway through now, but this is the answer to the calculation C. Okay, so the next step is now to calculate and show that AB plus AC will give us the same answer as that. So we continue with our example now, showing that the matrix algebra follows the distributive law, and we're going to work with this part of the calculation here. We'll be multiplying matrix A and B and add it to the product of matrix A and C. So that calculation is shown on this page, and we will work through it. We start with multiplying matrix A and B, and I've written them out here, matrix A and matrix B, and we have to see if they are conformable for multiplication, and we see that they are, because the number of columns of the lead matrix is 3, and the number of rows of the lag matrix is also 3. Okay? So what we can also tell is that the dimensions of the product matrix will be the same number of rows as the lead matrix, which is 3, and the same number of columns as the lag matrix, which is also 3. So if we denote the elements of the product matrix using C, and if we look at the subscript, we've got the two numbers, and what they tell us is essentially, for example, if we take this element here, the value of this element is calculated using the elements in the second row of the lead matrix, and we multiply those to the elements in the first column of the lag matrix. Alright, so as you saw previously, we can calculate all the values for these elements here by working through this matrix and essentially multiplying these elements together. So for this value here, we take the first row of the lead matrix and the first column of the lag matrix and multiply those elements together. 2 times 6 plus 1 times 1 plus 2 times 1, etc. Okay, so exactly how we did previously, you can work out the values of all the elements of the product matrix. Okay, so we won't go through it in detail this time, but you can clearly see here how the calculation is done, and the solution when we multiply A by B, A being the lead and B being the lag matrix, is as follows. If we now multiply matrix A and matrix C together, taking matrix A here and matrix C here, again using the same method, we can work out the values of the elements in the product matrix. Okay, once again, I've set this out quite clearly here. You can work through this example on your own, and the solution when you multiply matrix A and C, with A being the lead and C being the lag, is as follows. Okay, so the final step in this part of the calculation, we need to add the product of AB, the product of AC together, and that's what we have here. This is AB plus AC, and if we add these together, 15 plus 17 plus 32, 11 plus 16, 27, etc. What you can of course notice is that the solution to this calculation is, as we showed previously, they are both equal.